Ladies and gentlemen, Your Excellencies, dear young scientists, welcome, bienvenue, welcome to the 12th edition of the Expo Sciences Luxembourg.
Welcome. Welcome. 17 national teams from 12 different schools and universities, and 28 international teams from 16 different countries, but also all parents and friends who have come to support our young scientists.
Welcome. Also welcome to the partners, sponsors, and friends of the Fondation Jeunes Scientifiques Luxembourg. Also welcome to the Minister of National Education, Children and Youth, Mr. Claude Maisch. Welcome to Mr. Jean-Paul Berthemes, Head of Science and Society of the Fonds National de la Recherche. And finally, welcome to the Luxembourgish representative at the European Commission, Mrs. Anne Calteux.
The Fondation Jeunes Scientifiques Luxembourg is a not-for-profit organization with public utility, with the aim of supporting the next generation of scientists. This year, the Expo Sciences Luxembourg is no longer organized alongside the National Jungforscher Contest in order to fully prioritize on the laureates. My name is Dylan. I am a former scientist myself and have been a volunteer since. A friend and I participated in 2018 with a project named The Impact of Climate Change on Bees in the field of environmental science. This year, it is my pleasure to be a co-host for this closing ceremony.
Well, my name is Natalia, and just like Dylan here, I have a history with the foundation, although not as a participant, but as an organizer of the national contest and the Expo Sciences Luxembourg. And tonight, it is my honor and privilege to be your co-host for this first standalone Expo Sciences Luxembourg. And now, we would like to call on stage Mr. Carlo Hansen, who has been president of the Fondation Jeunes Scientifiques for the past 14 years, and who will be opening tonight's ceremony. Please welcome him with a big round of applause.
Minister, Excellencies, distinguished guests, ladies and gentlemen, dear young scientists, welcome to the closing ceremony of our Expo Science Luxembourg 2022. Like every collective venture, the foundation was created by a group of committed and enthusiastic pioneers. Thus, our respect goes to them and all those who gave and continue to give their unfaltering support. To all those who are here today, to all those who engage themselves for young people and for science, to all those who act today for a better tomorrow. Thank you. On behalf of our foundation, I'd like to especially thank you, Minister Claude Maisch, Minister of Education and Youth, Minister for Higher Education and Research, the representative of the European Commission, Mrs. Anne Calteux, the President of the National Research Fund, Mrs. Martine Reichertz, for your interest, for the interest you take in our young scientists and your commitment in the promotion of science and research. Thank you, to all volunteers who did a great job either by helping organize or run our Expo Science. Thank you, dear friends from abroad who found their way to Luxembourg and our Expo Science. Welcome to Luxembourg, a country that puts efforts in building bridges instead of erecting walls. Finally, thank you all for being here with us tonight to celebrate brilliant young minds and to attend the closing ceremony of this year's Expo Science Luxembourg. Lord Brown of Madingley, former president of the Royal Academy of Engineering, said the following to our participants in 2010 at the opening ceremony of the London International Youth Science Forum at Imperial College. Science is a natural home for optimists. This rings true because our national contest and the Expo attract many optimistic, enthusiastic, creative, and innovative young minds. Just take a look at the projects presented this year at Expo Science. It's an honor for me to encourage these young people and to provide them support together with the members of the foundation, our staff, and our volunteers. Looking at the projects and the achievements of our former laureates of the national contest, as well as the participants of our Expo Science, I can say, without any doubt, we are in presence of role models, which is why we should continue to encourage all these young scientists in their efforts and studies. Before we end this event, however, allow me to briefly remind you of the main objectives and goals of our foundation: to help young people discover their talents and develop them, to advise them on their path to entrepreneurship, to create and offer multiple platforms in form of the national contest, the Expo Science and Science Next, where ideas, knowledge, and craftsmanship exchanged and promoted, where young people learn to work together beyond and despite all frontiers, where they learn to take social responsibility, which is going to impact our all future. Ladies and gentlemen, you may ask yourself what the future looks like. I will show you our future now. Please, all young scientists, please stand up. Please. This, ladies and gentlemen, is our future. Thank you. And with the words of the late Mr. Stephen Hawking, and one final point, he said, we never really know where the next great scientific discovery will come from, nor who will make it. Opening up the thrill and wonder of scientific discovery, creating innovative and accessible ways to reach out to the widest young audience possible, greatly increases the chances of finding and inspiring the new Einstein, wherever she might be. Congratulations to all participants. Well done.
Et is als eng Eier, hau doch eisen Edukationsminister, den Herr Claude Meich, op eise Expo Science Luxemburg können ze begräßen. Mir gingen biden, den Herr Claude Meich op Bühne zu rufen.
Dear members and friends of the foundation, dear young scientists, when I look into this room, especially when I walked around this wonderful exposition, I saw a lot of creativity, because scientists, they want to create something new. They want to take something that already is known, combine it in a new way, and do something completely new that mankind has never seen before. But I also saw collaboration between young people working on their projects, being proud of their projects. And I saw them communicating. They created something and they explained what it was, how they did it, and what will be the benefit for other people. And they have a critical sense. They are not just repeating what others already did, but they really want to create something new. And creativity, collaboration, critical sense, and communication, those are important skills. They are the future skills for the 21st century. We need people with curiosity. And you, young scientists, you are curious. You are looking for answers on your own questions, and especially you are looking for your own answers on those questions. And you find your own way to solve problems. And curiosity and the will to find a new way, they are key for progress. And we need progress, especially in these times when mankind is facing some major challenges. The digital transformation, the energy crisis. We need new ways to make run this planet and to create a future for all the people on this planet. And we need scientific progress. We need technical, but also societal progress. And you are working on this. You are working for this, and you are burning for this. You are so engaged, and you are really want to bring something out of you and create something new, so that tomorrow it will be a better world. The world needs young scientists, and I'm glad to see so many here today. Thank you.
Als nächst inviteren wir auf die Bühne den Herr Jean-Paul Berthemus, den Head of Science in Society von der Fonds National de Recherche.
Hello to everybody. I'm really honored to be here because it's a great event. And I wanted to start with an anecdote. In fact, yesterday we had invited some friends at our home for dinner, and my son, he's 7 years old, he went out with his best friends, he's also 7 years old, and they looked into the stars with like a star map. And they were so happy to discover some star constellations. And then I told them that in fact when they look into the stars, they look into the past. And that if you would go to a star and look at the Earth, perhaps you could observe the dinosaurs. And they were really fascinated. And it was so cool for me to see, because that was really the first time that I considered myself to perhaps go into the direction of science, when I discovered this phenomenon of looking to the past and being perhaps possible to look at dinosaurs. And in fact, my son also asked me, but why can't we go there now, Papa? I said, yeah, I would love to go with you there, but it's a little bit more complicated. And now, today, I come here and I see again the same fascination in the eyes of so many youngsters here. So that really makes me happy to see this potential, this creativity. It's really, really good to see. Especially what I noticed is when I went around, that so many of the young people, they care about our planet, they care about climate change, they care about our health. This is very important too. I think some older generation, me included, perhaps we did not take care enough about our planet and about social inequalities and health, and you really care about that. And I think we really need science to tackle those societal challenges, and you really dare to do so. Also, another anecdote, I was working during the pandemic that was, in a certain sense, for science communication was perhaps good because people listened to science, but it was also bad because you saw that we have another big problem. That's the problem of the infodemic, so all the fake news that are currently going around. And I really believe that in order to tackle that, we need a better understanding of how science works. It's not about just facts, and the word facts is used too much because certain things are not certain, and science needs to build up things and changes constantly the way what it's considered the best way to go in a certain direction. And we need to develop a better understanding of that. And then when I see how many youngsters are here and really go into science and ask themselves a question they want to tackle and then solve it via the science, that's great to see, and that's what we need. It's also very important that you are here to explain it to other people. Science is good, but it also needs to be communicated in a very understandable way. So, again, I'm really honored to be here. We as FNR are really happy to support this event. It's easy for us because you do all the job, the youngsters do the great job, the organizers do a great job. I'm always impressed when I come here how familiar all this is. So yeah, we just want to continue to support you as much as we can because it's great what you do. Thank you very much.
All right, thank you to our speakers. And now we would like to continue with a unique musical performance from our Luxembourgish artist Edson. Edson creates alternative pop R&B music. His musical style is very unique to the Luxembourgish music scene and has been growing since the release of his first EP, NO, in 2015. Incorporating contemporary dance into his performances is just one of many things that sets Edson apart from his musical peers. He won Artist of the Year and Music Video of the Year at the Luxembourg Music Awards 2019. He was a support act for Mike Shinoda and also performed twice at the Primavera Sound Festival in Barcelona and By Me City Pro 2019. In 2020, Edson was one of the main acts for the Free Mobility concert, inaugurating Luxembourg as the first country in the world with free public transport. So, and now I would like you to ask to look upstairs and enjoy his performance.
Been running for 6 miles now. I don't think that you see me yet. Got blisters on my soles now. I do it cause it's necessary. Been hiding for a while now, but the trees are not big enough. Still breathing in that prana, cause my life's just about to start now. I am here for the ladies and the fellas stuck in between the non-binary. Your life's just about to start now. I'm here for the hustlers and the divas, the dreamers, the achievers. You raised me. If the money ain't there yet, if the money ain't there yet, focus, say your prayers, soon you will get there. If the money ain't there yet, if the money ain't there yet, focus, say your prayers, soon you will get there. Brothers and sisters, destiny won't show up somehow. LGBTQIA+, I will hold you down. I think my allies who are there to always protect the ground. To my true Boy, give me a kiss. If you let me persist, I'll bring you to bliss. I am the only one who shine when I slide. Jump into my jet, I get down when I fly. Just come a little closer, show me some love. Haven't you heard I'm the king of hugs? Haven't you heard I'm the king of hugs? What's that on your lip? Boy, give me a kiss, yeah. If the money ain't there yet, if the money ain't there yet, focus, say your prayers, soon you will get there. If the money ain't there yet, if the money ain't there yet, focus, say your prayers, soon you will get there. If the money ain't there, if the money ain't there, yeah. Hey, 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 hey. If the money ain't there, if the money ain't there, yeah, yeah.
Dylan? Wow.
Thank you, Edson, for sharing with us your amazing artistic universe. Now, let's be back with scientific topics. In a minute, thanks to les amis luxembourgeois de l'Université hébraïque de Jérusalem, we will welcome on stage Dr. Michal Sachaf. Her favorite subject was astrophysics, in which she won the National Olympiad in Israel. Fortunate enough to have received an excellent science education from high school up to her PhD, Dr. Sharaf is dedicated to offering young, talented people the opportunity to pursue their interest in science. Formerly working in a science museum as a science journalist, she now serves as the academic head and the physics lecturer at the Odyssey program in the Hebrew University of Jerusalem, and takes part in the program aimed at encouraging girls to study maths and physics.
Dr. Sahaf will focus on the notion of the scientific method as being mankind's most recent, revolutionary, and powerful way of understanding the world. Using relevant examples, she will discuss what good scientific thinking is, the limitations and benefits of applying the scientific method to the phenomena we observe, and ways to use the scientific framework to better understand ourselves and improve our life decisions. Please welcome Dr. Sahaf on stage.
Thank you. Thank you for the kind introduction. So I have been asked to contribute a talk to this wonderful event about science, which I can do. I've done that before. I've also been asked to say some inspiring words to the young people here. Something about your future in science. Now, I don't know if you've ever tried saying something about people's future. It's hard even if you know them, okay? It's harder if you don't know them, if there are many of them, and they're so different from one another and from me. So I'm sorry, Carlo. I'll talk about science. But then I came to think a little bit about, when I was a teenager, and I received some inspirational talks, and most of them sounded like this. Follow your dreams, use your gift, study science. I'm not saying this is a bad advice. It's just that when you go into the details, there's so many question marks. What is your dream? Is it your dream or somebody else's? And what's the best way to follow it? And what is your gift? How can you make best contribution? And how to use it? And study science, yeah, there's so many good reasons to study science. But which one is relevant to you? Okay, and which science? And what will you do after you study it? So I'm not going to offer you a lot of advice today, but I am going to try and offer you ways of thinking about questions, scientific questions, these questions as well, By the way, I forgot to mention, all the images that are not scientific were made with DALL-E 2, AI, artificial intelligence. So if you don't know what that is, Google it later, after the ceremony. So I'm going to be talking about the scientific method, and I will be using 2 examples. One is climate change. Everybody's talking about climate change, right? It's very relevant. The other is you and me, our lives, our decisions. There's a very big difference between these 2. Okay? Climate change is something that anyone can measure, anyone with the right tools. So it is a subject for scientific research. You and me, our experience, our lives, I wouldn't advise you to try and write a scientific paper about your experience and submit it to a scientific journal. They will probably not accept it. Okay, so these 2 things are very different. But as a person who's been educated as a scientist, kind of soaked in science, what I see is that the scientific framework kind of penetrates the way I think about everything. And what I'm going to try and offer you today is an understanding of what we do in science. Now you probably think, yeah, I know how science works. So yeah, I'm pretty sure you know, but I'll try and break it down into points so we can really talk about it. And I will also try and show you how we can use these points to study not only things around us, which is science, but also ourselves and our interaction with the world. So when we talk about the scientific method, yeah, that's DALL-E 2 as well. When we talk about the scientific method, there's something that I want you to keep in the back of your mind. Look at this timeline, okay? It tells us more or less for how long we've been on this planet. So tens of thousands of years ago, people like us were living on this planet. And they were as smart as us, they were talking, they were telling stories, they were sharing ideas. But the scientific method as such, as a prevalent way of studying the world, is new, okay? So it means that it's less intuitive to us than talking or walking or telling stories. We have to learn those things too. So that means that science is something we have to learn, okay? It doesn't come easy. So just keep that in mind when we talk. So a scientific work usually starts with an observation. If we're talking about climate change, an observation could be your grandmother telling you that it is hotter now than it was when she was a child. Okay, so that's an observation. People have been making observations all the time. A scientific observation of the same thing will probably look like this. Okay, so here we see results from multiple sources showing that at the beginning of the 20th century there was an increase in temperature. Then there was a small decrease. People were worried about it. Okay, they thought at the time that the Earth would cool too much. But then it started warming again, and now this is what people are worried about, and this is what is known as global warming. Okay, so we'll be talking about this. So what makes a scientific observation different from just any observation? We want it to be detailed. It's not enough to say that it is hotter now than it used to be. Okay, what does it mean? Is it that the hottest day is hotter than the hottest day before? What about the nights? What about the winters? And we want it to be accurate. Now, when we measure something, our tools will not be very accurate. They will have some errors, so we want to be able to estimate those errors. And we want it to be quantitative. Okay, how much hotter now than before? Now, let us put aside climate for a moment and talk about our lives. Observation is something that we all do. Okay, and observation can be something like, I did this project and I enjoyed it. At least I'm hoping you enjoyed your projects. I'm hoping you're not here because somebody forced you. Okay? Try and make it more detailed. What did you enjoy? Did you enjoy building something? Did you enjoy programming something? Did you enjoy studying something new and challenging? Did you enjoy it when people told you the project was good? Did you enjoy being praised for it? Did you enjoy working with smart people? Okay, try and make it detailed. Now, quantitative is not always easy when we're talking about our lives, but we can try and do that, like on a scale of 1 to 10. What did you enjoy the most? Or in terms of time, did you enjoy doing for like 2 hours a day or 10 hours a day? So we can try and borrow these concepts from science to our life, okay? It doesn't mean you can publish a paper about it in a scientific magazine, but we can learn how to use it. So the next step, once we have an observation, is the hypothesis. This is the story we tell, okay? We connect different pieces of knowledge by cause and effect. We're trying to say that this is the cause of that. And if we don't know where to look for connections, then a good place to start would be a correlation. Okay, correlations tell us where to look when we don't know. So a correlation means that we have similar pattern. For example, this is going up, and the other thing is also going up. Or we can have an anti-correlation. This is increasing, the other thing is decreasing. So if we're talking about climate, here's a correlation. The x-axis is the estimated number of pirates. The y-axis is average global temperature. And you can see that the more pirates we have, the lower the temperature on Earth is. When we have less pirates, and that's about now, we have a higher temperature. Okay, so there is a correlation. Well, correlation does not always imply causation, right? Either it could be a coincidence, or more often, it could be something else that is causing these two. And I will leave you with the challenge of trying to find what is causing the extinction of parrots, as well as global warming. When we're talking about a scientific hypothesis, it has to suggest a mechanism, and the mechanism has to make sense. It has to comply with other things that we know. So I also challenge you with trying to find a mechanism for the pirate thing. Okay, maybe the extinction of pirates does cause global warming. Okay, try and find something. I couldn't. A mechanism is not enough. We have to get the numbers right. Okay, maybe the mechanism works, but does it account for the warming that we see? Wouldn't it cause more or less? Okay, so numbers are important in science. And then it has to produce testable predictions, because otherwise it's just a story. Okay, and story is something that people do very well. But if we want the story to be a scientific hypothesis, we have to have ways of testing it. So here's another hypothesis you probably all know. Okay, we see a correlation between the concentration of carbon dioxide in the atmosphere and the temperature. They've both been rising. And we have a mechanism that you probably all know, and the suggested mechanism is called the greenhouse effect. We're getting radiation from the sun, and that is in many different wavelengths with a peak in the visible light, and that comes through the atmosphere and warms up the surface of the planet. And as the planet warms up, it radiates. It loses energy to space, so in this way it cools down. But it radiates mostly in the infrared light. And carbon dioxide and other greenhouse gases, they don't let that out, okay? They absorb infrared. And so cooling and slow down. And this is what is known as the greenhouse effect. So that's it. We've got climate change all figured out, right? We understand climate now. All good. Not yet, okay? A lot of people have been studying a lot of things and finding a lot of correlations. Some people have studying the sun, you know. The sun is very much related to climate. But not just how much energy comes from the sun, but also the magnetic activity of the sun. Okay, the magnetic activity of the sun has a cycle of about 11 years, and we see it changing through the number of sunspots on the surface of the sun. And it turns out that this 11-year cycle is not exactly 11. It usually varies somewhere between 10 and 12, and there is a very good correlation between the length of the solar cycle, which you see in red, and the temperature change. Or at least there used to be a very good correlation. Do you see where that ends? Recently, it became an anti-correlation. Oh, well, that's science, okay? Things are complicated. You think you have it all figured out, and then you find something that makes a total mess of everything. So it's not enough to have a correlation. Let's see if we can make up a mechanism. So how would the magnetic field of the sun be of any effect of what is happening here in the climate of Earth? It's a magnetic field, okay? It's not how hot the sun is. So scientists came up with a very interesting mechanism. The Earth is continuously being bombarded by particles, okay? Galactic cosmic rays, or particles coming from the galaxy, from events like supernova in the galaxy. And when they hit the atmosphere, they can stimulate cloud formation. And the magnetic field of the sun is like a shield. It can deflect them. So in this way, it can affect cloud formation. Most of you have been in the Science Museum a couple of days ago. Remember the cloud chamber there? You saw it, how these little clouds form as a result of particle coming in. So that's something very similar. Okay, there's the mechanism, right? Make sense? So we would quite often have more than one mechanism that makes sense, and the whole thing looks more complicated than we would like it to be. And it's actually even more complicated than what I said. Clouds. do they make the Earth cooler or hotter? When you're walking in the sun and there's a cloud, you feel cooler. But clouds are made of water. Water is an excellent greenhouse gas. So having clouds is like having a blanket over the Earth. Okay, so it depends which clouds, where they are, how high they are, how they move. And actually, if you look at the whole thing, it's so complicated. Okay, it's not just the galaxy and the clouds and the sun and carbon dioxide. It's other things too. It's the trees that people have been cutting down. Trees take up carbon dioxide, and they cut them because they want to make room for agriculture, to grow food for people. And food includes, well, cows, beef that people like to eat. And cows, well, they fart. Cows fart. And their farts contain methane, which is a greenhouse gas. And there's the ice in the poles, and the way that the water moves in the ocean, and the way that the air moves around the Earth. All this thing is so complicated. And we have multiple mechanisms. And that's when we come back to numbers. Okay, numbers matter. There's something known as climate sensitivity. I want to know if I am going to increase the amount of carbon dioxide, let's say double the amount of carbon dioxide, what will happen to the temperature? Okay, by how much will it increase? How sensitive is climate to any of those factors? Without the numbers, our hypothesis is not complete. And if it's not complete, we have to study more. So to learn more, we make predictions based on the hypothesis. Okay, predictions basically means what should happen under different circumstances, okay? Or where else can we see this effect? We can ask those questions, and then we can test the hypothesis. There are different ways of testing a hypothesis. So I'm going to go over these 3 ways, and I'm going to also mention how we can use them for our own study of ourselves. So, number 1 is an experiment. Number 2 is another observation. Number 3 is a simulation. An experiment is a great thing, okay? You build a setup, and you do whatever you want in it, okay? You have control of it, and you test whatever you want to test. The problem is that it is a simplified setup. So we have this Earth. It's very big, so it's hard to experiment on it. We also kind of want to live in it, okay? And if our experiment goes bad, then we wouldn't want to live here anymore, and we don't have another one. So we don't want to be running, and we cannot be running, experiments on the whole Earth. But we can build a simplified setup. So before I tell you a little bit about the kinds of experiments that can be done, let me go back to our lives. Experiment, is this something that we do with our personal lives, our personal decision-making? For example, when I was a teenager, and I was studying science like just for fun and reading, I thought maybe it would be a good idea for me to go to a science school. And this science school was actually a boarding school, and I was like 14 or 15, and that meant that I had to leave my family. It was a big decision. It was an experiment that I did in my life. And luckily, I enjoyed it very much. Okay? It was a good decision for me. And then later, I thought, you know, maybe if I'm studying science in school, I would love doing it in university. Because in school, it was just a few hours a week. In university, it would be all day long, for years. So I would have a lot of fun. And that wasn't exactly the case, but we'll come back to that later. So, experiments, global warming. We could, for example, test how significant is the effect of this infrared light being absorbed by carbon dioxide gas. Okay, we can take greenhouse gases and see if they do the effect that we claim they do to the amount that we need them to do it. We can try and create clouds in the lab, okay, and see if the effect that we expect to get from cosmic rays is what we actually get. So this has been done, this can be done and has been done. And there's something that I want to say about experiments, and that is that experiments don't fail. If they're good, if they're performed well, they don't fail. Even if they don't verify your hypothesis, even if they don't support your hypothesis, it's not a failure of the experiment. Okay, you have to update your hypothesis, yes. Okay, but you learn something. Every time you do a good experiment, you learn something. Same goes with me and my going to university. I learned a lot. First of all, I learned physics, of course. But I learned something about myself, the way I want to study. I realized that just sitting in class all day is not my way of studying. I don't enjoy it. It's not the best way for me to study. Later in my PhD, I could study at my own pace, read papers, take just a few classes. So I'm happy I did my degree in physics because it led me to where I am now, and I learned something. So that's important to keep in mind, okay? Your life experiments, if you do them well, even if they don't turn out the way you wanted them to, that's not a failure. And science experiments, the same. So another thing I want to tell you is that, this is not what an experiment looks like. This mess is what an experiment looks like, with all the cables and everything. Okay, don't expect experiments to be beautiful. Nobody bothered to make them beautiful. I was a little bit disappointed when I first walked into an actual lab. So don't worry about it. And your projects, some of them are very beautiful and some of them just work. It's perfect that they just work. Okay, it's also very nice if they're beautiful, but they're doing what you wanted them to do, and that's what matters. So going back to our hypothesis, we want to test it. So another thing we can do is another observation, which means that we're studying the same system. Okay, if we're talking about Earth, it's this, Earth. And the problem is that we don't have any control of this system, and also it requires complex interpretations. Let's say that I want to study the past of the temperature on Earth. Before people had thermometers, how would you do that? You need to study it by proxy, right? You need to study something that indicates the temperature. So you have another hypothesis, like in between. So that makes everything complicated. What about our lives? What would another observation be in our lives? You don't change anything, basically, but you try and notice, okay? So if I notice that I like the challenge, studying something new and hard, do I like any challenge? What about sports challenge? And what do I need to make my challenge enjoyable and not just make me totally miserable? So an observation means that you kind of have new eyes. You notice things in a different way. So sometimes those new eyes involve digging into the ice for kilometers. Okay, and what we see here is hundreds of thousands of years of a very good correlation between carbon dioxide and temperature. And I won't go into the details of how this is being done. Okay, that's a little bit too much for the time that we have. I'll just say that it is done by looking for certain isotopes. Okay, water has oxygen in it, and oxygen has different isotopes, and they behave differently in different temperatures, and it's a good proxy for temperature. And you can see that carbon dioxide and temperature have been correlated very well for a very long time. Okay, so that supports our carbon dioxide hypothesis. But what about cosmic rays? Here we see, over hundreds of millions of years, the flux of cosmic rays, that's a yellow one, that can be studied using meteorites, and the temperature, that's a black line here, that can be studied using fossils. And these are in a very good anti-correlation. When we have low cosmic ray flux, we have high temperature. When we have high cosmic ray flux, we have low temperature. So this has been, looks like, it has been driving temperature on Earth over a scale of millions of years, okay? So that's the kind of observations that we can make, and there are many, many, many others. And last, a simulation. A simulation is a computer program, okay? And once you have the computer and you have the program, you can run it again and again, and you can change all the parameters, and you can play God, and it's wonderful. There's only one big problem, known as garbage in, garbage out. The computer only knows what you tell it. If what you tell it is not correct, the results you get are not correct. If what you tell it is incomplete, the results you get are incomplete. Do we do that in our lives? I'm going to give you a moment to think what that is. What is a simulation in our lives? Do you use computers to understand your lives better? Most people don't. But we do use this computer a lot, okay? We use it to visualize different situations, to think about the future, to plan, to daydream. Okay, that's a simulation. If somebody is asking you, what do you want to do next year, or in 5 years, or in 10 years, and you have an answer for that, the answer for that is a result of a simulation that you run inside of your head. Okay, me thinking that if I go to university, I will have fun, was a result of my own simulation based on what I knew at the time. Remember, garbage in, garbage out. Okay, imagination is a great tool, but it has its limitations. So I'm going to show you now a simulation of kind of the worst case scenario. Okay, it's trying to show us what would be the temperature, the increase in temperature on Earth at the beginning of the 22nd century, assuming that carbon dioxide continues to accumulate in the atmosphere. And it's using different assumptions here, so you get a very big range between 3 and 7 degrees. Okay, so 3 is bad, 7 is horrible. And so what is true? Okay, it really depends on the assumptions that you put in. So a simulation is a great thing, but we have to remember its limitations. So basically, this is a scientific method. You do it, and you do it again. You draw your conclusions, and you update your hypothesis, and you do it again and again and again and again and again and again and again. And some climate scientists will die before there's a full understanding of climate change. Okay, science takes time, and also our own understanding of ourselves. It takes time. But sometimes your hypothesis will be well established, and then you can call it a theory. And then the next step would sometimes be, not always, but with some theories, to take it out into the world, take action in a way. Okay, so it can be a new technology or new methods based on what we've learned, and sometimes government policy. And sometimes we don't have a fully established theory, but we still have to take action. Okay, for example, governments now need to make decisions about what we do with global warming. Okay, we cannot affect the galaxy or the sun. We can train pirates. Maybe training like 5,000 pirates will help. We can eat less cows and more plant-based food. We can use less fossil fuel and other renewable energy sources. Okay, so governments have to make decisions, and people have to make decisions sometimes when we don't have a complete understanding. Okay? And same goes with our life decisions. Sometimes we need to make decisions and we don't have a full theory. Now, I don't have a full theory of my own life. I definitely don't expect anyone younger than me to have a theory of their lives. I honestly don't expect people older than me to have a theory of their lives. Okay? Because we are complex things and we are dynamic things. We keep changing. Same goes for the Earth. Okay, so sometimes it's very hard to know everything, but we can try and know more. So I would like to conclude with some science advice. I will try and make it both relevant to science, ordinary science, but also to the scientific way of thinking of understanding ourselves. Observe with honesty. Okay, quite often there are things we don't want to see, or we overlook. Perhaps because they bother us, or they look like something we're not used to. A lot of great scientific discoveries began with something that people overlooked. It looked like a mistake, it looked like noise, okay? But it turned out to be true. So start by being honest. You see what you see. Try to see as much as you can. You can later decide what to do about it, okay? But be honest with what you see. Be honest with your observations. Experiment bravely, but be careful. Okay, some of your experiments will have some consequences. Okay, definitely your life experiments, but also your science experiments. If you're working with people, if you're working with animals, think about the consequences of what you do. Yes, be brave. Okay, if you don't do things, you will not learn new things. But try and think about consequences. A great way of thinking about consequences is simulations, right? So don't forget to keep updating your simulations. Don't fall in love with your old simulations, okay? That's something that happens to people sometimes, and they don't like to take in new data. They say, oh, this is probably a mistake. I will ignore this new data, okay? So that comes back to, observe with honesty. And if other people have an observation, listen to them. Don't make fun of them. Listen to them. Maybe they're seeing something that you're not. And be open to changing your mind. People fall in love with their own hypothesis. Scientists get attached to their hypothesis, okay? They get stuck in science, and people get stuck in life because we're not willing to change our minds. So keep in mind, your hypothesis right now is good. It's a working hypothesis, okay? Use it. But remember that it may not be perfect, and be open to changing it. And most importantly, be true to yourself. It is a scientific fact that every human being is a unique individual. And a unique individual means that we're all different, okay? You're not your mother, you're not your father, you're not your best friend. You're not your sister, you're not your brother, you're not some role model you admire. You're you, okay? So you have your own perspective of things, and that is your perspective, and stand by it. I think it's very hard to make a good contribution, and it's very hard to have a satisfying life if you're trying to be somebody else. So yes, follow your dreams, use your gift, study science, but most importantly, be your own scientist, first of all. Okay, get to know yourself, because no one else is going to do it for you. I wish you a wonderful future, which means that even if at times you will not have success, at times you will not have fun, but I hope you find wonder in the world and in yourselves. Thank you very much.
Thank you, Dr. Sachaf, for your remarkable presentation. As you certainly already know, our national and international young scientists have been competing with their scientific projects in their respective countries and won Expo Sciences Luxembourg as an award for their scientific work. Just a quick recap of how the Expo Sciences Luxembourg is run. Laureates from all around the world, aged between 11 to 21 years old, independently work on their research project. They then submit a written report of their innovative ideas, which is assessed by their respective jury panel. Next, they present their projects and face the jury's questions, which might be scary at first. This year, it has been incredible to see our 45 teams of 69 young scientists from 18 different countries present their projects in such a professional manner. Now, we have the chance to relive some great moments from this year's Expo Sciences Luxembourg with the upcoming short movie. Enjoy.
Welcome to the 12th Expo Science Luxembourg.
Well, that was something. And now it's finally time to reward our young scientists for their amazing work on their projects with an official certificate. So for this, we would like to welcome back on stage Mr. Claude Maisch, Mr. Carlo Hansen, and Mrs. Susanne Young, Director of the Fondation Jeunes Scientifiques. Please. Die könnt ihr stellen, wo ihr wollt. All right, so our first country of the evening will be Austria. Please welcome delegation upstage. Who's the supervisor? I would also like to ask the supervisor to come up on stage, please.
The second country to come on stage is Bulgaria.
All right. And our next delegation, who is going to come up here, is from the Czech Republic. Who is the supervisor?
The next delegation to come on stage is Denmark. I would also like to ask
No,
the
it's okay. It's okay, she's on there.
All right. Supervisor is here.
It's okay. All right, next up is Estonia.
Next, we're calling on stage the German delegation with their CEO of Jugendforst, Mr. Sven Bastio.
Next, I would like to welcome on stage the delegation from Israel.
Please welcome the Italian delegation on stage.
Now, I would like to ask to come all Luxembourgish delegations on stage. Please. Uh-oh. You know, hiding in the shadows. You can go down here if you like. Oh, okay, great. Nice. Everybody's. Well done.
Continuing further with the award ceremony, let's have a short musical break. Please welcome back Edson.
They called us weird. They called us nerds. But that doesn't matter. They don't have to believe in us. What matters is that we believe in us. Am I only half of what you see? Or is faking morals better than being free? Were you talking to me or were you talking to Harry? Cause I don't need no commentary. If it ain't useful for me, then don't compare us. It ain't useful, so I don't really care. No, 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 I'm so done with hiding my flaws. Don't wanna play the game I so often lost. I'm aiming for higher, 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 higher. I'm aiming for higher, 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 higher. You just keep taking everything, everything and more. I can't keep being everything, everything and yours. My baby's gonna love me for who I am. My baby's gonna want me for who I am. I'm stuck on two sides. One's really, one's a lie. Taking control of my own life, done keeping this inside. My body's not for your consumption. Red lips with a bold expression. Talk to me with a little more passion. More passion, no. I'm so done with hiding my flaws. Don't wanna play the game I so often lost. I'm aiming for higher, 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 higher. I'm aiming for higher, 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 higher. You just keep everything, everything and more. Can't keep being everything, everything. Baby, will always love me. Baby's gonna love me for who I am. My baby. My baby, I just can't keep everything in my heart. My baby's gonna love me for sure. Hey, 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 yeah, for who I am. Hit me. Hey, yeah.
Wow, thank you so much, Edson, again for such an amazing performance. So, and now we would like to welcome on stage Mrs. Christine Pegel, Director of the ANEFOR Agency from the European Commission. So, a little bit about the Mobiscience. The aim of the Mobiscience program, which is supported by the ANEFOR Agency, is to work on the development of scientific culture through the organization of local events aimed at young scientists from Europe and beyond. The Youth Mobility Program is a continuation of a pilot project from 2018 that supports scientific exchange of young people from Belgium, France, Spain, Luxembourg, and Morocco. All right. So, I would like to welcome on stage our first Mobiscience country, Belgium, with a supervisor, please.
Next, please welcome on stage the French delegation with their supervisor.
All right, our next Mobisions country is Spain. Please welcome on stage. Well, and now to something completely different. As you may know, or not, during the past couple of days there have been another contest going on right next to this here hall, next doors. And it was a Beat Saber contest. Yes, there's someone very excited about it. And I would like now to ask the person who won the first official Beat Saber contest on stage. And this is, I hope I pronounced it correctly, Marion Caband. Marion. Well done. This time I'm congratulating you. And Marion, this is your prize. Oh, all right. Marion is being knighted. Applause to Lady Marion. Please don't run away too far. Oh, no, no, no. Just go in, here if you like. Yes, in the middle of the corridor. So you can see the screen really well. I'm just going to go over there. And I would like to ask all the participants of the Beat Saber contest to please stand up. All of you. Yes, yes, please stand up.
All of you.
Please, all the participants of the Beat Saber contest, whoever participated, Carlo, I know you participated as well. Oh. And we will have a last Beat Saber, not contest, but video, and you're very welcome and encouraged to dance away. One last time. And Lady Marion will show you her moves. Whoa!
the middle.
Thank you so much, Marion. You can now take your rightful throne. I can safely say I will never forget that music again in my life.
Definitely. All right.
Let's-
This performance was quite extraordinary.
Let's just welcome on stage, back on stage, our people for the Carlo Hansen, Mr. Maisch,
Yes.
to Susanna.
Let's now continue to award our young scientists coming from all around the world for their great scientific work. As we continue, we call on stage the Mexican delegation.
Well done. All right, our next delegation comes from Nigeria. Please come on stage.
We now call on stage the Portuguese delegation. Next, I would like to ask on stage the Turkish delegation. As for the last country for today, please welcome on stage the Tunisian delegation.
We would like to congratulate all our young scientists for their participation. Well done. Also, a big thank you to the members of the Fondation Jeunes Scientifiques, as well as their sponsors and partners. Thank you very much. And last but not least, we want to thank all the volunteers, without which this event wouldn't have been possible. Thank you so much. Could I just please ask all the volunteers and members of the FGSL team to come up on stage for a last group photo? Please, come on stage. Don't be shy. Here's enough space. Come closer. I don't bite. So, and before you run away, we have a very special person has her birthday today. And for this, I would like you all to sing a very, very nice happy birthday to Daniela. Come in the middle. Come. And 1, 2, 3. Happy birthday to you. Happy birthday to you. Happy birthday, dear Daniela. Happy birthday to you. Woo! Oh, come on. Thank you so much.
We are now almost at the end of the event. But before ending, we would like to ask Susanna Eyang, Director of the Fondation Jeunes Scientifiques Luxembourg, to stay on stage for her closing words.
Thank you. Thank you. Minister, Your Excellencies, distinguished guests, dear laureates, ladies and gentlemen, we have been looking forward to organize this in-person Expo Sciences Luxembourg for more than 2 years now, and especially this year, the Expo Sciences is no longer organized alongside the National Young Fouché Contest to get its own event. And I'm very pleased to stand here after these beautiful days with our 16 guest countries. So the Expo Sciences Luxembourg is an important occasion for our international laureates to join our national laureate here in Luxembourg, to exchange about scientific idea, but also to exchange about their respective cultures. And it has offered participants the opportunity to showcase their achievement and commitment in science. And because we are convinced that such a platform brings a lot to them, we are proud to count more than 500 young participants who have benefited to this platform. So one of the great joys of my job is to getting to meet these young people. Dear young scientists, the work that you've done really is inspiring, and I really like to show all of you my most profound respect. It's really hard to describe how impressive they are, the work they've done. So, ranging from neuroscientific analysis to AI tree classifiers, defibrillator drones. We also have the honor to welcome two laureates from the most prominent European contest for young scientists, so the UCIS organized by the European Commission. So Uri from Israel and Ellis from Estonia. So all these young scientists are a testimony of the potential that awaits us when we inspire young people to engage in this scientific journey, tackling tough problems, testing new hypotheses, trying and failing over and over again until they finally succeed. So please, a big round of applause to all of them. Dear participants, you are about to be launched into life with many challenges, but honestly, if you can work together, as you did throughout the Expo Sciences Luxembourg, you will overcome any situation. I would like also to express my deep appreciation for the efforts of every supporter of the Fondation Jeunes Scientifiques Luxembourg who have made this event an overwhelming success. First, the board of the Fondation Jeunes Scientifiques Luxembourg, who have made this event a great success. I cannot find my words. So, famous merci, Carlo Hansen and Simon Hansen, Paul Euchling, Lucien Hoffmann, Emmanuel Servet. I also warmly thank, yes, please go ahead. I also warmly thank my special team, so Daniela Arcon, project coordinator, Edouard Rozeski and Hannah for animated all the activity, but also spotlighted this event and especially our youngsters. Of course, Mrs. And of course, my dear assistant, so Mrs. Luisa Vadilo Andrade, to assist me in each stage of this event, All the volunteers who came to help by force or by will, I thank you, honestly. To the very competent Natalia and Dylan, moderators, thank you so much. Our gratitude goes also to the Ministry of National Education, Children and Youth, the Luxembourg National Research Fund, the NFR Agency from the European Commission for your fundamental support, which allows us to run efficiently. Not to mention our partners and sponsors and media partners. I want to thank Mr. Joël Mangen for having organized and supervised all technical aspects, the artists, Edson, Naomi, DJ Septi, and the whole focus team, my kids for being my first sources of inspiration. Last but not least, to all family members and also teachers for the special dedication. Big applause for all of them. Dear laureate, we have been proud to meet you in Luxembourg, and thank you for participating in the Expo Sciences Luxembourg 2022. I take also this opportunity to inform to all our young Foursher that the next edition of the National Young Foursher is going to take place here as of 16 up to 19th of March. And before share food and refreshments, I invite every young scientist to come on stage for a family pictures.